We proceed to our next and final speaker for this session. So I welcome Silvia Casu. Or Casu, it's okay? Yeah. And you're going to talk about hunting for, sorry, fireball, is that right? Fireball?
FRBs, fast radio button.
Sorry.
Can you hear me?
Yeah, we hear you very well. And you are going to explain to me what it is. Thank you. You have 20 minutes.
I'm here to explain. So welcome to everybody, and thank you to be here today. My name is Silvia Casu. I'm a staff astronomer at the Italian Istituto Nazionale di Astrofisica. In particular, I'm also the public outreach officer of the Sardinia Radio Telescope, the major radio facility in Italy. And I'm here today to present an activity based on real data, radio data developed with my colleagues Maura Piria, Matteo Bacchetti, and Matteo Trudu. Most of us are maybe more familiar with visible light astronomy to study stars, galaxies, planets, clouds of dust and molecules. But visible light doesn't tell the whole story about an object. To get a complete understanding of an object or a physical process, we need to study it in as many wavelengths as possible, including the radio range. Astronomers around the world use radio telescopes to observe the naturally occurring radio waves to reveal otherwise hidden characteristics of almost everything in our universe. Italy, in particular, has a long tradition in radio astronomy research due to the presence of 3 radio telescopes, the 32 meters telescopes and then in Noto and at Medicina, and the pretty new Sardinia Radio Telescope, SRT, the 64-meter radio telescope I work for, operated by the INAF Cagliari Astronomical Observatory in collaboration with some other institutes. In the last few years in Cagliari, we devoted large efforts in developing programs dedicated to radio astronomy public outreach, in particular to radio astronomy education. So we created some introductory videos, realized the virtual tours of our antenna, designed some laboratory and hands-on activities for children, activate some collaboration, for example, with Alma for the translation in Italian of their Talma Comics stereo. Most of these activities have been published in a new Italian magazine completely devoted to astronomy education called EduINAF. So let me take a few minutes to introduce you the activities of my institute, the Istituto Nazionale di Astrofisica. For many years now, my institute is deeply involved in public engagement activities scattered through the whole Italian national territory, and including dissemination and education, communication, and public and historical heritage promotion. In particular, INAF has 2 main registered official magazines: EduINAF, which is devoted to astronomy education, and Media INAF, which is for astronomy public communication and dissemination, plus some some websites for specific projects like AstroKids or the Astronomy Olympics game, and or for innovative education methodologies like Play Enough. So GHOU is a new Italian magazine for astronomy education. The chief editor, the director of this magazine is Silvia Giacomini. GHOU deals with the traditional formal and not formal education activities, and is targeted to students and teachers of any school levels, but it's also caters with a wider audience. For example, is targeted to parents, which are the new teacher assistants in the COVID era, but also to researchers who are interested in public engagement, general public, and of course some amateurs. Among the many things that you can find on GHOU, there are some proposal for educational paths. Using already published or new resources, in the last year, each month, we presented a different path with different subjects ranging from moon to gravitational waves, and linking different resources in a coherent path and presenting different educational methodologies. In particular, last June, we proposed a path completely devoted to radio astronomy and the study of radio waves from the cosmos. Here you can find the link. Unfortunately, it is in Italian, but it's just to give you an idea. The fact is intended as a mere suggestion for teachers of any levels, and so it presents some in a current way some introductory videos and infographics, and also laboratory and hands-on activities to be performed by teachers in classrooms, with or without the help of staff astronomers. One of these activities is the one I'm presenting today. It is devoted to an intriguing topic in radio astronomy, the fast radio burst, or FRB. I know that this acronym is not very famous, and this is because fast radio bursts are a pretty new mystery in modern astrophysics. They are intense bursts of radio emissions characterized by a very high intensity and very short duration, something like a millisecond. The first was discovered in 2007. I thought it was actually observed some 6 years earlier in archival data of a pulsar survey in Magellanic clouds. FRB, as I said, are a big mystery. Given their speed and unpredictability, observing FRBs is a complicated and, of course, sometimes frustrating activity. But when you do, of course, is a great satisfaction. There are not many example of FRB now, but a lot of them have been discovered in recent years by the Sardinia radio telescope. They are characterized by this typical paraboidal behaviors. This trend depends on the fact that the signals undergoes a dispersion during its journey from the emitting source, for example, a distant galaxy. During this journey, in fact, the signal is slowed down by passing through different kind of types of matter. A slowdown that works differently from frequency to frequency. The delay is related to the distance and indirectly to the amount of matter crossed through a quantity called dispersion measure. We are finding the dispersion measure allows to disperse the signal and obtain the pulse, the characteristic pulse of FRB. We also decided to design an educational activity called Hunting for FRBs, whose main objective is to inspect some sets of real data taken with the Sardinia radio telescope, looking for possible FRB signals and, in case, correct them for dispersion measure. Obviously, in doing this, students should also develop some hard and soft skills, like understand the problem solving, understand the step of analyzing real data, develop the digital competence, and so on. To perform the activity, students should have a stable internet connection and a Google account. This is required because all the provided data are stored in a drive repository space. And to inspect and analyze the data, students will access a collab space using online computing resources. We provide step-by-step instructions through video tutorials, but we are also preparing written helping resources. We provide 8 data sets of radio observations taken with SRT and pre-calibrated and cleaned for radio interferences for simplicity. So step 1 is to download and inspect the data, then find the correct dispersion measure, decide if the data set presents or not an FRB, and finally corally discuss the obtained results. In particular, how does it work? After copying the data in their own folder, students can familiarizing with the provided code written in Python. It is not necessary to know anything about coding and programming languages, but we think that it could be useful for them to see how the code is made and structured, and to better understand the analysis steps. The most interested student could also afterwards try to modify the code to see what happens. The FRB code allows tuning different time steps, visualize the data, and tuning the different dispersion measure to obtain the final signals. Anyway, in order to simulate the most realistic observation experience, not all 8 data sets present the signal. So it's a real hunting game for students. The activity is designed for secondary school students, but we in EduINAF you can also find some activities on radio maps creation designed for primary and middle school students to understand how we obtain radio images, also with the use of coding activities like pixel art. So, in summary, we recently proposed educational activities on radio astronomy to be published in Italian EduINAF magazine. One of them, Hunting for FRB, is based on real data sets taken by Sardinia Radio the Italian Sardinia Radio Telescope, an activity which is currently under test and updating phase because we published it in June, and so we didn't have enough time to work with the students and teachers. We plan to complete this phase in September, in a couple of weeks. Unfortunately, as I told you, all the activities are in Italian, but the English version with the teacher's sheet is under progress, and we plan to submit to AstroEdu site. Thank you so much. If you have any question, just okay, I'm here. Thank you.
Thank you very much, Silvia. This is indeed a very interesting and challenging, I guess, educational proposal. It is. Yeah. I say it's very interesting but challenging, I guess, because
yes, it is. But it's well, our main idea is to reproduce the real life of an astronomer.
Yeah, sure.
And in lot of activities, there is the guaranteed final success. But it's not our life. Our life is to inspect a large volume of data, looking for something, and a lot of times we don't find anything. So it is a real hunting because well, we guarantee that in almost one set there is an FRB, but the students are pushed to inspect many times the data, to visualize them in different configurations, to understand, not just to push some buttons, but understand what they are tuning, what the meaning of what they are doing. Of course, the data are simplified because they are cleaned, they are calibrated, they are prepared for students.
Silvia, I would like to give the questions that you have from the participants.
Yeah. Sorry.
So you have a somehow natural question, I guess, by Christian Goesteran. Why doesn't Italy participate in the International Astronomy Olympiads? And this year will be Colombia.
Sorry, I didn't understand.
The question is, why doesn't Italy participate in the International Astronomy Olympiads? And then I guess you could participate with this project, I guess.
With the Olympics, the Olympiads?
Astronomy Olympiads. Astronomy, you know, the Olympiad that we are.
Yeah, okay. Well, Italy is participant. There are two different
let me.
Yeah, two different International Astronomy Olympiads. And so maybe we are participating in the other one, but we participate nationally and internationally.
Just ask Christian to clarify his questions or his questions.
Maybe we can just compare the different.
Okay.
I mean, it's not the Columbia edition, so the other one. I know it's very strange. There are two different competitions.
Christian wants to specify his question or not. In the meantime,
Hi, Emanuele.
Go on, Christian.
Good morning, Colombia, Silvia, and Emmanuel.
Hi.
This year, Iowa is in Colombia in November. In other years, Italy don't participate in the Iowa. It's the International Astronomy Olympia and Astrophysics. We hope you participate this year in our country. is virtually, but we hope you present with your country.
Okay. But maybe Silvia, if you don't mind, because it's a little bit shifted from your presentation, this question.
Yeah.
So we can just have the question of Risto before we stop. Risto asks, how would you compare your project to the project from ISA that is called César? If you know this project. It's a project César. Maybe Risto, you want to explain? You can have.
The next exposition, Greg from Poland, he talked about that topic. Yes, the next conference with Greg.
I don't know.
Okay.
I
I think we should call for the break now.
Yeah. Maybe Risto, you can send a mail to Silvia and.
Please continue the discussion on the chat.
Exactly. So it is time now. We have the break before the keynote speaker.